Thank you for joining our BigQuery workshop. Today we are going to continue our BigQuery and GCP series. Let's start with a brief recap of what we learned on our first workshop. Let's go through the presentation that I showed previous time. We went through the different types of, let's say, what is it like a database, data warehouse, and data lakes briefly. So we use database for storing and writing transactions. We use data warehousing for analytical purposes and just data lakes for storing different types of data. And Google BigQuery is one of the most popular solutions for data warehousing on the market. It's very popular. And in terms of architecture, we have a decoupled storage and compute. They're just separated and they're connected with some network between each other. And this architecture helps to work really fast and with a good performance with the queries and with the data manipulation. So this is like how infrastructure looks like, and how it works. So for compute, we have Dremel is compute, let's say service in Google, and we have different layers in it, and they're serving different purposes. Another thing that we covered last time is a comparison between Google BigQuery and Snowflake. Snowflake is another popular data warehouse solution. Talked about what are the differences, and Snowflake you can work with different cloud infrastructure, and BigQuery is mostly for GCP use only. Also, there are some differences in terms of automatization of partitioning and some other features. So we went through how to start working with the BigQuery. You can run a sandbox, which is good for starts, as you don't need to provide any credit card information, but also you can create a GCP free trial that includes some like money that you can spend on different services. You need to specify your credit card number, but then you can just cancel it if you want. Yeah, the BigQuery project is a high level thing in the BigQuery. You can store in the project different data sets related to some departments, and in each data set you can store different tables. So this is like how BigQuery project looks like. Also, we covered the difference between traditional databases and BigQuery storage, or like data warehouse storage. In traditional database, the data is stored by rows, which is good for writing the data. So it's mostly used for OLTP transactional databases, and for column, like BigQuery stores in columns. So it's really a good way to store for analytical purposes, as you need just if you query the data, it needs much less data, to process this data, and BigQuery charges you for the amount of data processed. So the columnar way of storing it is a really good way. And we covered two main things for optimizing the, let's say, the data. First, it's like partitioning. So you can just divide your table, your data into different segments based on the date or some integer columns. You just pre-order it. And then we covered our clustering methods. You cluster also, you just based on some columns you specify, or like you pre-order your columns based on some fields, and it helps BigQuery to more easily process the data, and the amount of data is less than is not clustered data. And today we will cover some new topics, and the first topic for today will be how to load and ingest data into BigQuery. There are just two different types. First type is use direct import, just load data directly to the BigQuery to its own storage. Or you can use external tables. For example, you can have a data in your Google Sheets, and you can query directly this Google Sheet data from the BigQuery. The difference is that the data is stored outside of BigQuery, and your query will be much, like maybe not much, but it will be like slower comparing to the query that you will apply to the table that is stored in BigQuery. This is main difference. If you want to have a good performance, query performance, and you need just data frequently, it's better to use just tables in BigQuery, not external tables. There are different types how you can ingest data into BigQuery. I think the most popular is just batch ingestion. Also, like there are other types like streaming, data transfer service, query materialization, or partner integrations. Let's cover all these topics. Yeah, so what is batch ingestion? You just load your data, like some data sets, at regular intervals. It's not real time, so we can load just every once a day or every hour, every like 20 minutes. Yeah, and you don't need to pay for these loads because these like BigQuery loads are free. So you just pay for storing and querying the data that you loaded. And yeah, of course, there are some different formats of the data that you can ingest. And based on the type of data you want to ingest, the ingestion time varies. Yeah, so the first file format we'll talk about is Avro file format. As you see, it's like binary row-based format, and it's just the fastest file format that can be uploaded into BigQuery. Another just relatively fast upload is for Parquet or C data types. They are stored in a columnar formats, and it's really to ingest, really fast upload. But for maybe some formats that we mostly use to, like CSV or JSON, they are not as fast as previous formats because how they structure. There are different methods, and we will try some of them in our console. The first method to load the data is just using BigQuery UI. We can open the console that we created last time, or you can create it like once again. We have our project. For example, Surfalytics test partitions is a project that we created last time. Let's try to upload some data into our BigQuery table. We have a data set, test data set. Let's try to create a table. And as we see, there are different ways where we can create data from. Of course, one of these is just Google Cloud Storage, is a storage in GCP, or we can just upload it from our desktop. And there are other type of storages that are supported by BigQuery. It's Amazon S3 or Azure Blob Storage, just two quite popular ways. But let's try to just upload file. We need to select maybe like a CSV file. So we can ask ChatGPT, please generate simple CSV file. Simple data, desktop.
You ask the GPT generate data for us that we want to insert?
Yeah, just let's like as an example, we don't. Yeah, I just asked. So it's just three fields and some.
Can
data
you upload in the chat so we can just download it?
Of course.
You can drop in the chat the link to your project in GitHub.
I think I need to add. Yeah.
Oh, you don't have it. Okay.
Yeah, it's in Notion. Yeah, I have the first webinar. We have it in our GitHub. I think after the meeting, I will add the second part that I.
Sounds good.
Yeah, I will share after. Yeah, but let me add the file. I will add to our channel in.
Okay. Yeah, perfect.
Now we can go to our Google console and just. And BigQuery automatically understand that this is like a CSV format. Also, we need to specify the table name. Let it be simple table. schema. Schema is the definitions of the rows and data types that we have in CSV. Let's auto detect it. Let's allow BigQuery to auto detect. And also there are some possibilities to do partitioning, but let's not do this time. So let's just create table. Yeah, and we have our data and the schema. The schema is like a description of the table was automatically generated. Its name is string, age an integer, and city is string. We just uploaded our data using UI. The next type is using CLI. We will load data using CLI a little bit later. And let's just briefly describe some other possible options. The next option to load data is using REST API. REST, I didn't know that before, but REST is like a representational state transfer. It's just a way how we can send data to BigQuery using some internet requests. We can use like different languages like Java, Python to send this request. And in return, we get the response in JSON format. This is how we can use this API to load the data. Also, there are some managed GCP, like Google services, that we can use to load the data. One of them is just Dataflow based on Apache Beam. It's just we can create a data pipeline, and it can upload data in both batch or streaming modes to our BigQuery. Another tool is called like Dataproc. It's a GCP service for Apache Spark and Hadoop. And the last one is like cloud logging. This cloud logging tool is just mainly focuses to load logs to BigQuery, not the data, but just logs to load to the data. And here the overview of all possible things, can UI, API, tools, or yeah, these services that allows us to load the data. And what is going on behind the hood? What BigQuery helps us to do. So when we are loading the file, the data is automatically encrypted and encoded. Also, it's like sharding. Sharding is like it's partitioning and like clustering. It helps us to store the data in a certain way to reduce data procession and encryption, and it helps to geo-replicate our data to store the data across different locations automatically, just for better accessibility and security, I believe. What about streaming ingestions? Also, there are some services that helps us to stream the data. There are like actually 3 that I mentioned here. The first one is Cloud PubSub, Cloud Dataflow that we just talked about, or like a serverless option like Cloud Functions. Here's an example of how we can use Dataflow for both streaming and batch processing. And so we have some real-time events, and we have some data in batch load. And for streaming, we can use Cloud PubSub, and it streams directly into the Dataflow as well as the batch pipeline, like a batch data. And then Dataflow automatically in parallel can load this batch and streamline pipelines into the BigQuery. It's one of the benefits of this Dataflow service. And then we can use our analytical tools to analyze or create reports. There are some other ways to load the data. The first is like a data transfer. It's just, I'd say, built-in service to BigQuery that helps to move data from like different data warehouses or like storages into BigQuery. It's like an easy way to import data into BigQuery, but we will not cover it today. In terms of, there is like a query materialization. If you want, you can create query results. So you write a query, and then if you want, you can materialize this query into this in our BigQuery warehouse. Or we can query without loading the data, as I mentioned before. So there are some public data sets that we used in our previous workshop, or we can share a data set and use some shared data sets that are created by others. Or there are some external sources, as I mentioned, like having data in Google spreadsheets and externally querying this data into BigQuery console. There are some partner integrations that we can also use in BigQuery. And let's try to load data with our CLI tool. And yeah, let's do it going through the lab that is provided by Google. Let's go. First of all, we should log into our Google console. And yeah, we should create a new project for this. New project. CLI load project. The project is created in the process of creation. And then we will use a Cloud Shell. Yes, it's built like a CLI into the Google Cloud, and we will use it to load the data. The project is created. Let's select it. Nice. And here is the icon for our Cloud Shell. Okay, yeah, we got access to our Cloud Shell. First, we need to run the following command to confirm that we are authenticated. GC Cloud auth list. Okay. Yes, permission to use the CLI. Okay. I think we got this output.
Can you drop this link into Teams chat? Or you drop it in Discord, like this one tutorial?
Yeah, I can drop in Discord. So I just dropped it in Discord. So next step is we should run the following command, list project, to confirm if the gcloud knows about our project. List project. Yes, CLI load project that I created, so the CLI knows about it. We need to create data set is like collection of tables, and we need to, and it stores in the same, all the tables are the same data location. So we need to create a data set, and we use it just with the CLI commands. So BQ, so BigQuery make this data set. Data set is successfully created. Let's check it. Use BigQuery, BigQuery Studio, our CLI load project, and we see our data set, BQ load code lab that we just created. And using BigQuery show command and the name of the dataset, we can see some information about it. see the data about the dataset. Everything is good. Yeah. And we need to create a CSV file. First, we can create a CSV file. Yeah, and we use just a standard CLI command, touch, that we can use in other tools like other CLIs to create a CSV file. Customer. And we can open this file by running Cloud Shell edit command. Let's try. We see our file and we open it, but it's empty, because we just created an empty file. And we can just copy some data to this file. Okay. And we should save it file edit.
Maybe on the left side. Yeah, here.
Save. Yeah, thank you. File and save. Okay. And now we can, run the following command to load it into the BigQuery. Let's just check what we are doing. The command for loading is bqload, and then we specify different settings for this file. Our file format is CSV, source file CSV, and we skip the first rows because the first row will be our header row with the headers, column names, and we specify BigQuery load, the name of the table where the data should be loaded into. And the second argument is our table name, which defines which file will be loaded. And or there is an example that we can load file. So if we have some data in cloud storage, we can just specify the link, the path to this file in our cloud storage and load it in the same way. And this is, I think, a schema of this file. Let's use this query.
What are the use cases for CLI from your experience? When do you need? Because usually, you work with data warehouse, SQL clients, you write the SQL or like different BI tools. When you think CLI will be helpful?
Loading the data?
Yeah, or loading the data, maybe anything else. Like, is it part of ETL process? Why we might need use CLI?
I don't have like much experience with BigQuery CLI. I think it will be helpful for maybe some settings or for some maybe automatization. You can have some scripts that you can run, and then will help you just to quickly use some tools in BigQuery. Maybe like somebody who use like CLI in BigQuery can share their experience on our call.
No, I think my question was not about BigQuery, but just the CLI. Like Snowflake has CLI, right? There, for example, probably Amazon Redshift doesn't have CLI, but AWS has CLI. And we're not using BigQuery CLI. We're using Google Cloud CLI. It's the same as Azure CLI, AWS CLI. I think it might be helpful for some automation. Whenever we're using CLI, it could be part of automation job. Or because theoretically, you can use Python, for example, to dump the data from API and then load this data with pandas like a SQL Alchemy library into database. But instead, you can, for example, dump data from API and then use CLI to push the data to cloud storage or from cloud storage to push to BigQuery. I think the key here is just the alternative way of doing similar task. And yeah, the probably CLI is very helpful for automation. Or when you have CI/CD process, right? Then GitHub Actions, you usually leverage only CLI. It's the same that you use CLI to run dbt commands. It's like part of your pipeline or automation things, something for this.
Good point. Thanks for sharing. Okay, yeah. So let's load this data. Mm. And the data should be loaded. The status is done. And we can verify it by just checking these tables, BQ show, and the dataset name, and then table name. And we see our table with the schema details. And the same we can use our UI, I think. Yes, we can refresh it and we see our table. And let's preview the data, and we have our data in the BigQuery. And as we loaded the data, now we can query it. And we can query it in a CLI as well. The command is BiqQuery. And some flag and the SQL code. That's right. Okay, yeah, and we see our data. And total state code, nice. So we use some our table, customer transactions, and we joined some public dataset information based on the zip code area, and we just grouped it. Here's the explanation of what it was query about. And now we can delete our dataset, BQRM, and the flag R, yeah, and the dataset name. Do we want to remove it? Yes, and it's removed. Refresh, yes, and we don't see the dataset here. We just went through the process of loading data using the CLI. We used the shell command line to do it, and used some BigQuery commands as well as gcloud commands to create a data set, to create a CSV file, and we just added data to the CSV file and then load it, create a table and load it to this data to the BigQuery and tried to, and even executed some queries using CLI, and then just delete This is an example of how we can load data with the CLI, or in general, how you can use CLI in BigQuery or in GCP in general. Let's talk about some ways to query the data. Yeah, BigQuery supports some standard dialects of SQL. There are two types of query jobs that can be executed. The first one is an interactive. They're just executed as soon as possible, or batch queries. They're queued, and yeah, you can even schedule a query job that will be processed in some time in the future. There are different types of tables in BigQuery. The first one is just manage table. So it's just a regular table that is stored in BigQuery storage, the same table as we just created. External table is with the storage outside of BigQuery, like spreadsheets. Standard use is just a view. It's a table defined by SQL query, which is like, I would say, updated when we reference this table. This SQL query under this view is running every time we use this view. Or materialized view, it's something I would say between manage table and view. It's a view, but it stores some cache results for some period of time. So when we reference frequently this materialized view, the data is not, I would say, if there were no change in data, the data is not updated, and we don't spend our money on data processing for materialized view because it stores for some period of time. As we talked in our before, the schema is just a description of fields and type of fields in our tables. The data types could be like some simples, or simple like date, integer, like string, or there can be more complex like array or struct. Yeah, for some nested or repeated values, we will cover it later today, or even some, I don't know, column modes, required and repeated. We will also see in some nested and repeated data later. And so how this SQL query works, we have our data sets and data in BigQuery, and as a user, we create a SQL query and we run it. And BigQuery creates a query job that is referencing this data, and the results are stored temporarily, or if we want, we can store the results like permanently. Once again, BigQuery scans only the needed columns. The best thing is not to use all fields if we don't need it. It's better to specify columns that we really need and just run only them in our query, just to reduce the amount of data processing. Let's check some query capabilities like saving queries, sharing, and in our console. Let's go to one of our previous projects and try to find some data. Here we have some data stored here. And we can query this table. We just ran this data. And as we see, the number of data processed is just 0 bytes, because the results, I already ran the similar query some time ago, and we just used like the results of this historical query to get this information. So I haven't spent any data on it. We haven't spent any money. Also, there is like a job history, so we can check and see what queries I ran like for some time, and we can even view this job in editor and run it once again. We can just check and see it. Also, if we need to run this query on a regular basis, we can save it. We can save this query or save it as a view. For example, this.
Where can we get the query?
I can share this query, but you can just open, if you have a project, You can just find the table. If you have data set in the table, you can just click on dots and just write query, and then you can run it, and then you can just use these functions to save query.
And this is this table like managed?
Yeah, this is a managed table, so it's stored in BigQuery. If you want some aggregations for this table or something else, we create a query, and then we can save this query just separately if we want to use this query frequently. Let's try. And as you see, we have in our project, we have queries folder, like queries section. And here we can see the query that I just created. And we can just save it and use several times. So if we create some complex query that we want to run frequently, we can just save it here, or we can save it as a view. Let's and we just saved it as a view in the dataset that we specify. We can use our query as a just saved query, or we can save it as a view, and then we can reference this view, and we can mostly views I use some intermediate tables to just aggregate some data and just some intermediate step, and then we can reference it and query it in our another query. This is like a standard view. It allows us to simplify some complex queries, or for users, if we have some business stakeholders, we can create for them a query and save it as a view. They can reference it and use the data that they get from this query. Let's just talk about once again about materialized view. So materialized view, they are storing some cache results and for some time. If we reference this table, they can use like these cache results, and so there is no like data processing things, and they are updated with some periodically, or they have refreshed periodically from the main table. But there are some limitations for using materialized views, or one of the limitations is that you can't use joins for materialized view. It means that you need first maybe create another query with join and create some managed table based on it, and then you can create a materialized view to reference this table for some data aggregation or some other things, but without any joins.
Nikita, can I ask a question to clarify? So the base table should be the table, not the view or another materialized table, materialized view, right? Should be table, and only on top of that you can create materialized view.
I can double check. I don't know exactly, but I think so. Yeah.
Okay, thanks.
Yeah, I can double check if we can do it for some other types, but I think
I had this question on the interview.
And what's your answer?
Actually, I didn't answer on the materialized view question because it was in the beginning. And yeah, I didn't know it's like using additional caching for materialized view.
Got it. Okay. Yeah, let's check it and sharing the after the workshop. And another topic is joins and nested and repeated data and some maybe more complex data types. I think you all know different types of joins, like inner, right, and left. Maybe we can just once again, for those who don't know, cover some cross join and what is the difference between like I don't know full join or cross join. FPC, the full join is joins. We have two tables, and each joins Okay, for instance, if we want to join by color, we have like 1B as a final table with 2A, and then we see that in first table we have 3 as a red, but we don't have like red here, so it creates additional row with 3, and because we don't have data here, it's just null value. And the same for the second table, we have yellow C value, but we don't have yellow values in the first table, so it just creates a new row with just null value in this field. But the cross join is just takes two tables and it creates all possible combination of data from two tables. One, and it creates, and if we have like 3 rows in second table, it creates all possible variations with all possible variation with the fields that we have, all the rows that we have in the cycle table. 1, 1, 1.
Can you drop this picture in Discord? Maybe we have this coding page, I think, where I put through about the SQL.
How it's called? It's like a specific
coding
channel? Coding,
yeah. I usually like Python or SQL. Or maybe you can download it and then attach. The cross join is I still not fully understand, and sometimes it's happening. I see sometimes in even DBT models the cross joins. For me, it's hard to understand the reason, because you see it's like just multiplying each row from left on each row from right. And for example, I had 2 cases. One, we had sales by day, but we didn't have sales every day. And then we had in CTE something like calendar. They specify date start and date end, and you have like, I don't know, 2 years of dates. And then you cross join your calendar with 2 years of dates with your sales. That's not every day. And maybe the reason was to show, because then you visualize this, you have, for example, March 1st, March 2nd, and then March 6th. So it's the gap on the line chart. But if you will cross join with calendar, you will get like 0 instead of just empty. It's like to fill the gaps with zeros. I think this is one of the popular use case in DBT modeling.
Yeah. Actually, I use the same approach in my company because I needed to create something like sales performance dashboard for our sales team. And the issue is that we have a sales reps and we don't have sales like close deals every day. To fill in these gaps, we just need to join all the possible dates from some standard calendar with all the sales reps. It just helps to fill in the gaps between the data. Maybe there are some other solutions how to fix this issue, but have actually the same thing there.
Yes, sometimes in BI tools, I think maybe even in Tableau, there is special feature to fill the gaps, like because it's common cases. But yeah, and I think the challenge with cross joins, it's probably influence bad on performance of query.
Yeah, because there are a lot of fields that we actually don't need, or like with empty data, just a filler.
And I think another very, very important topic is this optimizing join patterns, because this is coming from like related to query plan, related to performance. And this is probably the most popular question on interview. Then they want to ask you what you go do if your report is slow. And the answer is, yeah, you need to, from BI report or from pipeline, you need to get the SQL query, and then you need to see the query plan. And then in query plan, you will start to see joining patterns, because we are talking usually in context of analytics about distributed clusters, and BigQuery is distributed, Snowflake is distributed. This means more than one machine. So then you're running on Postgres or SQL Server, usually have just one machine. And it's also called SMP, like symmetric something. An alternative is a distributed one, it's MPP. Then you have like multiple machines running together. And the data could be stored differently on different machines. And then you need to join everything together. You need, I don't know, copy the data between, for example, broadcast join, right? You have small table and you have large one. Large table distributed even, for example, evenly, ideally among all your nodes. But the small table, it's small. You can just copy paste this to each node, and then you can have local join on each node between small table that's fully cloned and portion of big table, and then you can like start joining result. But that's probably the only thing you need to know about performance and performance related questions, how to get the query plan and what you can find inside query plan. Everything, Spark, Snowflake, BigQuery, they all have these kinds of joins, and usually they limited number of them. And some of them bad. I probably broadcast join is bad. And if it's starting doing this with big table, and there is also, I think, shuffle term exists, but yeah, I'm not good in this, but it's something, yeah, everyone need to know how to answer this question.
And there are some, yes, like examples how you can optimize, or some of the best practices.
But first you need to identify that you have this problem, right?
Yeah.
For example, skewed join, right? How you can identify? You couldn't just identify it because your query took long time. Then you need to see the query plan, and you need to able to identify. This is data engineering work. Then we talk about you the data infrastructure. For example, okay, you create the Google BigQuery, you create some roles, you create the storage accounts, some permissions, maybe networking setup. But then you design your data warehouse, especially in the cloud data warehouse. Now, the most important topic, how you're going to design the tables, because you can think about, okay, I'm going to design the dimensional modeling. This is nice. It's data modeling, but now because we usually talk about lots of data in cloud data warehouse, could be terabytes. For each table, you need to design this in the way, does it has like sort key or partition key, cluster key, indexes, or all those things control how the data will store it on the disk on node, and it will influence the performance. Then you will query this data, read and join. And usually it sounds complicated, but if you just, for each data warehouse, you can write down like, I don't know, 5 points. For example, Redshift, distributed key, sort key. Snowflake usually works as a service. You can optionally add the cluster key, but the idea that Snowflake using micro partitions and it works as a service, you don't do nothing. In BigQuery, I think Nikita will cover what options you have in BigQuery, then you create big tables. In Synapse,
I think we covered this, that we can use partitions and clustering.
Yeah, we ideally need like cheat sheet, right, for each product. What's the technique? And then you basically can answer the question if they ask, okay, and it's popular question even for analysts. If your report is slow, what you gonna do? And it's a tricky question, because if you don't understand how things works, you won't reply it. But if you understand how it works, or you know the answer, you will tell them exactly what you want. And it's like low-hanging fruit. If you can answer this question, if your report is slow, what you're gonna do? If your pipeline is slow, what you're gonna do? Answer the same always.
Oh, I like in Snowflake a lot of things are automated, but we should know what is automated, because on one, I think on one interview that I had, I get a question about how you can optimize the query in Snowflake, and they said, oh, you can like partition and clustering, but they said, oh, but it's like already managed there. So you should know that in what data warehouses is like managed by service and where it's not. Okay, and yeah, like here's an examples. So the broadcast join, it means that if you have two tables, large and small, you should use a large table first and then join the smaller one. Yeah, for the hash joins, you have two tables and they have some matching keys, and you can use this matching keys or hash keys to join these two tables to improve this. Or you can use clustering to join these two large tables. That will improve like reduce the data processing. And yeah, for self joins and for cross joins, it's better to avoid using self joins and cross joins. They are just too expensive, and not the performance is not so good. So it's better like pre-aggregate or use some other techniques rather than use like cross joins and self join. And for data, like for skew joins, what's the issue? So if we have like partitions in table and they can be like uneven, it means that for some, there could be some partitions with a lot of rows, one partitions with a lot of rows and another one with small amount of rows. It's slowing the query performance. And we ideally should some perf like filter or aggregated the data before partitioning and then just use partition to have more equal partitions in this table. Another topic is denormalizing the table. And when we are denormalizing the table, sometimes it's good because if we denormalize the table, we won't need to use joins. And some of the things that we can use is nested or repeated fields. This is an example of nested or repeated fields. I can also put it in our Discord. Instead of joins, we just have this, in this example, we have just table and transactions table and customer table. And instead of using join, we have it in one table and the customer data is nested into this transactions table. It means that it's stored as like nested data. We will look at an example later. And the data type of this nested information is a struct or record. Yeah, and to reference this nested data, we use the name of, let's say, the table and dot the name of the field that we want to specify in query. Repeated fields, they are stored, like for instance, we have transactions and we have product, and we have fields with the same and rows with the same data for the product. And if they are one order at a time, and inside this order we have several products, several quantity and prices, for this order we can store it as repeated fields. And the data type for this repeated field is array. To have to flatten this field, we will use like unnest command, yeah? Or we can use a combination of nested and repeated fields. In this example, we have transactions, and for one transaction, we have one customer as a nested field, and we have product for this order, several products that we bought in this order as a repeated data. And this type of array structure record complex data types, they are supported by several formats like JSON or Avro and some other file types. Let's check how it looks like. And here is an example of the nested field. We have our
sorry, Nikita, quick question. Then we have nested field or JSON, and we want to store it inside column in the table. What the column type, data type it is? Is it like string or BigQuery support? For example, in Snowflake, you have data type variant. That means it is some nested structure. And I think in Spark, it is array that give you this ability. In what if we decide to store this JSON in one column? Does it has any special data type and table?
For nested, I think it's a struct or record.
Okay, yeah, because I think that the benefit of the difference, then you store it as a string, you're not able to parse elements. But if you store it as the right way, probably here is a struct record, you will able to work with as an array or JSON, so you can specify that you want a nested element or the like return only ID or only name values or only type values, something like you can basically in Python JSON. And the JSON is a very popular structure, by the way. You should know how to work and interact.
Good question. I think it's stored like as a structure record. In this example, we have our transaction and customer tables, and the customer data is stored as a nested data. We have field names like ID and type, ID and time that we have here, ID and time, and yeah, ID is an integer, time is timestamp, and these like both are required fields. And the third field is our nested field. customer with the type of this nested field is record, and the fields that we have in this nested field, they are specified. Here we have customer ID as a required field, and customer name and customer location. This is how it looks like, and it's like in the customer column or field has like a data type record. And as we see here, the BigQuery automatically flattens nested field when querying. And if we want to reference some nested field, we can use these structures, customer dot and the field name. And here I think is an example of such data. So we have order ID, we have timestamp, and we have some struct data and another one. And here we see the result of this query. It was like information about the nested field. Another type that we mentioned is repeated fields. It's stored, it's like as an array, or it can be also stored as a record data type. And here's an example, the same example, but with another table, like products, have order ID, order time, and we have products, and we have several products, and we have SKU, description, quantity, and price, and the data format is a little bit different. We have for one order, we have several products, and it's stored in as an array or as record, as we see here. And to flatten fields, these group fields, we can use this unnest clause or like function. And here's an example of usage of this function. So we have our order ID, we have our timestamp, and here's just hard-coded examples, have hard-coded numbers. And in nested, we just have this data, hard-coded data, and we just choose all the columns, and Google BigQuery automatically flattens it. We don't need to use any additional functions here. But for repeated data, we need to use unnest function and specify the repeated field name, and Google will and BigQuery will flatten it. We created table here with the hard-coded numbers, with hard-coded data, and then we just created a query and referenced order ID and our repeated fields with a nested function where we specified like the product is the repeated field that we want to flatten. And we got this result. From this data that was stored in this format, we got the following result with the use of a nested function.
How you will share it with us?
I think I will share it in GitHub. Or you want to just practice?
No, I think we now do it.
We can do it right now.
In Discord, drop as a code. Those tables, are they exist in BigQuery, or you preloaded them?
No, you see, this is the thing. This is just hard-coded numbers. We just created with the hard-coded numbers. You see, like order ID, hard-coded, timestamp, hard-coded, and then it's just to show that we don't need any specific functions to flat. We use here like a struct to have a struct field customer. This is a customer ID, customer name, and location name. And we just don't need to do anything with it. We just reference it and we get all the data in needed format. And the same for repeated. This is an example just to show that we need a nested product. And here is just hard-coded numbers that I use as an example. It's not referencing any table, so we can just run it, and we will get our result. You got the idea?
Yeah, if you share those queries,
okay, yeah, I'll share in GitHub after the workshop. And this is the last example. This is like a combination of nested and repeated fields in one this is how it looks like. We have ID, time, we have a customer name, and we have one customer. And then for one order, we have several products that are stored as a repeated fields. And this is the structure. We have order ID, time, customers as with a record, type records and fields. And here we have product also type record, but with the mode repeated. And this is the fields of the repeated products. And here is another example just to show how it looks like. These are the hard-coded numbers. We just create our order, and we have our struct data as a customer, and we have some repeated data as an orders. And then because orders are repeated, we use unnest to flatten it. But for customers, we just don't need it. We just reference it like customer name and get our data. It's just like a combination of two options. And yeah, actually, that's it for today's workshop. Do you have any questions? My plan was I will share the GitHub of this workshop today. And for the next time, I was going to create a project, BigQuery with dbt. We will set up a dbt project connected to BigQuery, load data to the BigQuery, and transform it with dbt. And after that, maybe there will be one more that will use a tool called Dataflow. It's a Google Cloud tool, like similar to dbt.
Thank you.
Thank you. Thank you. There are some differences, so I would check the differences and to see what are the differences between dbt and Dataflow. Yeah, if you have any other suggestions for our workshops, feel free to text me.